Hello everybody. In this screencast we're going to learn all about sequences. So let's start out with a definition of a sequence. So here's a mathematical definition. It says that an infinite sequence is a function whose domain is a set of positive integers. That means no fractions, no negative numbers, positive integers. And the function values, we say that's a sub 1, a sub 2, a sub 3, a sub 4, all the way out to a sub n and beyond. These are called terms of the sequence. So this is your domain. These little numbers right here, 1, 2, 3, 4, all the way out to infinity. If the domain of the function consists of the first n positive integers only, the sequence is a finite sequence. Okay, so all that means is if n is 10, that means you have a finite sequence of 10 terms. If n is 100, you have a finite sequence of 100 terms. If n is infinite, then you have an infinite sequence. It never ends. Okay? So in plain English, a sequence is just a list of numbers. That's all it is. Now we usually have rules to tell us how to create a sequence. For example, here we're asked to write the first 4 terms of the sequence given by a sub n is 2n minus 6. So that means that my first term is a sub 1. And that means everywhere there's an n, I'm going to put a 1 in. And I get 2 minus 6, which is negative 4. So a sub 1 is negative 4. A sub 2 means wherever there's an n, put in a 2. So that's 4 minus 6, which is negative 2. A sub 3 is going to be 2 times 3 minus 6, which is 0. Are you seeing a pattern here? And a sub 4 is 2 times 4 minus 6, which is equal to 2. So this sequence, every term increases by 2. Okay, n can be anywhere. So how about this one? A sub n is 2 raised to the nth power plus 1. Write the first 3 terms. So a sub 1 is 2 to the 1 plus 1, which is 3. A sub 2 is 2 to the second plus 1, which is 5. And a sub 3 is 2 to the third plus 1, which is 9. You can have sequences with terms that alternate in sign. And the way you do that is you just raise negative 1 to the nth power. So watch how that works. A sub 1 is negative 1 to the first times 2 times 1 minus 1. So negative 1 to the first is negative, and then 2 minus 1 is 1, so I get negative 1. How about the second term? Now negative 1 is being squared, so it's going to become positive. And I'm going to get positive 4 minus 1, which is 3. We'll do one more. A sub 3 is negative 1 cubed. Since negative 1 is being raised to an odd power, it's negative. And inside I have 2 times 3 minus 1. So I have negative 6 minus 1, which is 5. So sequences can have negative and positive terms. Your graphing calculator can plot a sequence. To do that, you just go to Mode, and you make sure that the sequence mode is selected and that you're in dot plotting mode instead of connected. Okay, and when you're in that mode now, when you hit y equals, you don't have your familiar y equals anymore. Now you have a minimum n value, and you have a u sub n that you can plot, a v sub n you can plot, or a w sub n you can plot. So you can see that I've already put this 3n minus 6 in here into my u sub n, and I'm going to go to my window, and my starting n is 1, my maximum n is 10. That means I'm going to plot 10 points. So that means that along the x-axis I can go from 0 to, let's say, 12, just so we have room. And if I put in 10 for n here, I'm going to get 30 minus 6, which is 24. So my y-min can be 0. And we can let my y-max be 25. and we'll let our y-scale be 5. So when I graph that, there you can see the plot of the points going up. Each point, when I hit trace, hang on just a second. When I hit trace and then use my right arrow, it shows the points. This is the third term in the sequence and the value is 3. This is the fourth term in the sequence and the value is 6. Fifth term in the sequence and the value is 9. So you can see it hopping from point to point in the sequence. Now these dots are not connected because remember that our domain is integers, no fractions. So they're discrete points. So I'll grab that and put that down here for us. And I'll go ahead and put our y equals screen in there. Okay, so you can use your graphing calculator to plot sequences. You can also define sequences recursively. To do that, you need one or more of the first few terms and then the recursive definition. So in this example, we say the 0th term is 1, the first term is 1, and the kth term, you don't have to use n, you can use any letter you want, the kth term is a sub k minus 2 plus a sub k minus 1. Alright, how the heck does that work? Well, I already have the 0th term and the first term, so the next term I need is the second term. So a sub 2, according to our recursive definition, is a sub 2 minus 2 plus a sub 2 minus 1, which is a sub 0 plus a sub 1. And we were given those. So that's equal to 1 plus 1, which is 2. A sub 3 is going to be a sub 3 minus 2 plus a sub 3 minus 1, which is a sub 2 plus a sub 1. Okay, a sub 2 is 2, and a sub 1 is 1, so it's 2 plus 1, which is 3. Let's do one more. A sub 4 is a sub 4 minus 2 plus a sub 4 minus 1, and I get a sub 2. I did this backwards up here, didn't I, guys? I just realized I made a mistake. Anyway, 3 minus 2 is 1, and 3 minus 1 is 2. So same idea, same result. I just need to switch those. There, glad I caught that. This is going to be a sub 2 plus a sub 3, and that's going to be 3 plus 2. Do you see the pattern here? What this is telling us is every term in the sequence you get by adding the previous two terms. And this is a real famous sequence. It's called the Fibonacci sequence. So it goes 1, 1, 2, 3, 5, 8, and so on. And it pops up in nature all over the place, and we'll probably talk about it more in class later. Okay, one other thing we need to understand when we talk about sequences are factorials. So factorials work like this. If I have a number n with an exclamation point next to it, that means n factorial, and that means multiply all the integers from 1 up to n. So for example, 5 factorial is going to be 1 times 2 times 3 times 4 times 5. So that's going to be 2. 2 times 3 is 6. 6 times 4 is 24. And 24 times 5 is 120. So factorials get really big really fast. Luckily, our calculators can do that for us. All you need to do is go to Math and arrow over to PRB, because we use it in probability a lot, and there's our factorial, number 4. Okay, so let's do 12 factorial. I'm going to put in 12, Math, arrow over to PRB, hit number 4, and 12 factorial is a very big number. Okay? Now, when you work with factorials, there's a weird little rule about them, and that is down here, which is that 0 factorial equals 1. And that's just by definition. We have to make it work like that. Otherwise, lots of rules of probability won't give us good answers. Okay, last thing. Sequences can use factorials. So if we want to write the first 5 terms of this sequence, a sub 1 is going to be 2 to the first over 1 factorial, which is 1 times 2 over 1, which is 2. A to the second, or a sub 2 is 2 squared. Whoop, I'm messing up a lot today, aren't I? That should be 2 raised to the first power, which is 2 over 1. There. Okay. A sub 2 is 2 squared over 2 factorial, which is 4 over 1 times 2, which is 2. A sub 3 is 2 cubed over 3 factorial, which is 8 over 1 times 2 times 3, which is 8 sixths, which is 4 thirds. A sub 4 is 2 to the 4th over 4 factorial, which is 16 over 1 times 2 times 3 times 4. Okay, so we can take out an 8 in the bottom, leaving us with a 2 right there, and we get 2 thirds. And finally, a sub 5 is 2 to the 5th over 5 factorial. That's 32, and we just figured out up above that 5 factorial is 120. And so you can reduce that. Let's see, that's going to be 16 over 60. Take out a 4, and we get 4 over 15. Okay, so that's pretty much all you need to know about sequences. The next screencast you're going to watch is all about series.